was just explain some of the functionality of this binary search function in Python, the video that was on the website. It's a rather excellent video. I want everyone to actually copy the code out and actually get this to work. It's a rather good video. What it doesn't explain in detail is how what's happening at each stage of the search. So what I've done is I've actually added a few more bits of code to this code here, and by doing that I'll explain how the code actually works. First thing is, you don't actually have to have this little bit of code here, if underscore name underscore that. We'll leave that later on. That's actually some of the definitions in Python actually create an object. We'll leave that for next term. So we can omit that line there, and this is what I come up with in Python. This is the code I come up with here that I got from the video. You'll notice I haven't got this line here, the if name equals main, that section there. But then I've indented the code back to here as well. It's exactly the same. There's my list, and I'll show you how it works. So if I go now, I want to go run. It's over here, unfortunately. It says what number you're looking for. Now I'm going to say, I know there's a number in the list, I'm going to say 12. Now what I've done, I said 18. 18 is actually in the middle of the list, and remember how this actually works is it searches first, it works out what the bottom of the list is and the top of the list, then it works out the middle of the list. Because I've actually smacked bang win on 18, it's actually got the bottom of the list, the number is 0, and it's number 1, 0 index, which is number 1 here. The middle is 18, and the top is 58. Now the first if statement, it says if it's actually the middle, yes, number found, true. This is a while loop, so it'll only work while that number is not found. Because it is found, it'll go if it's found, and if it's found, it'll say here, if it's found, so it's true. It'll then say your number is in the list, else your number is not in the list. Now how it works is the bottom number is 1, the middle is 18, 58. Then it says is it 18? Yes. So let's see what if we get a number that's not quite in the middle. So I'll say 27 this time and see what happens. Okay, and as I said, I'll check 27. Now this, you can actually see it actually working in stages. So the first thing it does, what number you're looking for is 27. We know that the bottom number is 1, the top is 58, the middle is 18. Is it 18? Well, it isn't, so it's actually higher than 18. If it's higher than 18, then basically what happens here, this section here, so the bottom now becomes the middle plus 1. So you'll actually see the index of the bottom index is 0, now that index becomes 7. Alright, it's because the middle index is here. Then the middle index actually shifts up. So what happens is now we're now searching from 19 to 58, and the middle index is 31. So the question is it 31? No, it's lower, so therefore this works. So the top now becomes the middle minus 1. So the top index was 58, was the top number, now it's 27. So there our range is much reduced. The next question is it 24? No, it's higher. So now we're only searching now, we're searching 27, 27, 27. Now the problem is that's not in the list. Oh yes, it is in the list, sorry. Is it 27? It's higher. If it's higher, then that becomes the bottom becomes that plus 1, and therefore we're right on 27, and it works out here, but the number is actually found. Interesting case, what happens if the number is actually right at the extremities, is 58, or it's 1. So we'll run it again. So this time I'll go 58. We go through quite a few more lists out now. What number you're looking for? I'm looking for 58. Is it 18? No, it's higher. Is it 31? No. Is it 43? No. Is it 58? Can you see how the index is changing each time? So we're trying to go for the middle, the middle, the middle. So that's how it works. It's quite a really elegant program, and I've added a bit more functionality so you can actually see it working now. Just the last thing I want to do, it's interesting cases if I pick 19. That's another interesting option. What number you're looking for? I'm looking for 19. Interesting thing about this one is at 18, the middle number is 18. It's higher than this. Now the middle number now is 31 of that list. So even though it was only one away, it has to then go to here. Then it goes back down to the middle, 24, and then it actually finds that it's actually 19. Still, it's a lot quicker than searching through 1, is it 1, is it 4, is it 6, is it 8, is it 12, which would be a linear search. So binary search is still a lot shorter option. Okay, so I think I'll leave it there. What I will do is I'll leave this bit of code here so you can, if you want to amend your code to see some of the extra functionality I put in to make it work. Now what I'll be looking for in the program that you do today is I want to actually see some more comments, and I want you to experiment with some of these, try to get some different outputs, and I want you to really know how this works. Because your next outcome, you'll be doing this. I'll be getting you to search through a list. It won't be ordered, so that's another thing we'll need to work out. How do we order a list? How do we get it into the right order, the right ascending order? And that's what you need to do. I want you to copy this out, and I also want you to put some comments in. Each line should have some comments in, and I want you to have a crack at this. So here is the code. It's just about all of there. So you should be able to do a freeze frame on this video. Copy all this out. Make sure you understand each line of code, experiment, and get it working before the end of the lesson.